you kind of do everything up front, and then it's reliant on subsystems and making sure that all the subsystems work, and then you build on top of that. So it's a decomposition and then a recomposition with a lot of testing so that you don't have failure.
Exactly. Yeah. And so with that V method, we're really taking time to deliberately break down the component into the requirements, that subsystem, and then the specific aspects of what we're trying to engineer the solution for, and then slowly testing and building it back up. And it's really good for high-risk domains because we don't want to be putting ourselves in a position where we just throw something out there, and if it's buggy, we learn because the rocket exploded, right? We want to make sure that we've got the solution figured out, and we've done small-scale testing and slowly grow that back up until we get to the entire system for that final kind of evaluation before it's then put out into the real world. Good. All right, any questions about what we covered last time? Yes, exactly. So the PDCA approach, and what does that stand for? Either Emmanuel or anybody else? Yeah, so plan, do, check, and act. Yes, plan, do, check, act. Yes, perfect. That's great, guys. Yeah, and so what about the plan, do, check, act cycle? What's kind of a major takeaway from that? Oh, yep, go ahead.
Try to put your solution into action,
Mm-hmm.
and you check and see how it did, and just act accordingly, whether it helped with the problem or you have to go back to the planning phase.
Exactly, yeah. So you're echoing what some of the people here on the chat are saying. It's really iterative, right? It's not just a ballistic linear approach. It's not a one and done. It is a constant iterative improvement or attempted improvement. Perfect. All right. Again, any other questions about what we covered last time? Awesome, pretty straightforward. All right, here's your fun fact of the day. Andrew Jackson's parrot was kicked out of his funeral for swearing. How about them apples? I promise not all of my fun facts are bird related, but they have been the last couple classes. I think Andrew Jackson was also the president that somebody broke in to his residence to try to assassinate him. And he wound up beating the guy to within an inch of his life with like a fire iron while he was an old man. Not necessarily the best president, but an exciting one nonetheless. All right, so today we're talking about evaluation, right? And this is largely to standardize how we're going to be talking about evaluation throughout the semester, right? Because people are coming from different backgrounds, engineering and psychology. We'll also get people who are communication arts rather, in this class. And so we want to establish, okay, what is kind of the standard process for evaluation that we're going to be referring to for the rest of the semester? And the why we need evaluation should be fairly straightforward, right? There's a ground truth in the world, and our goal is to figure out what that ground truth is. I like to think that I went into the sciences because I was obsessed with Mythbusters as a kid, right? And it's this idea that we have some question about the way the world works, and now we need to go establish whether or not that is, in fact, the ground truth. We need to be able to say concretely that something is the case, and that gut instinct isn't a sufficient basis for design, right? So we've already talked about some of these examples of wherein we either have these adages in the English language or where gut instinct has steered people wrong, right? So think back to the stovetop example. It seems like on the surface level, no pun intended, On the surface level, it seems like, okay, that's a reasonable design. But then when you start considering those second and third order effects, there are very negative consequences associated with those types of designs. And then my personal favorite, very passive-aggressive line that I hope you all take out of this class is that the plural of anecdote is not data. People love anecdotes, right? They love, well, this happened, so obviously this is the ground truth of the world. And those of you all in psychology know that we're inherently attuned to very specific things happening in our world, right? This is where we get a lot of the heuristics and biases. And so wanting to get what is the objective ground truth that we need to consider. Somebody thought it was a good idea to put that touch screen in that F-35, not considering the fact that when you're vibrating at supersonic speeds, it's hard to touch a touch screen, right? So get at that ground truth, that scientific evaluation method. So the type of questions you all are going to be asking, either in your group project for the semester or when you get out of this class, are things like, does the existing product address the real needs of people? Right? And so you'll see a lot of times, especially small business owners who have a product and they love this product. Frequently, their entire net worth is tied up in this product, right? But they think it's answering a question that it's not actually answering. And so your job when you come in is to help them see what is the real problem we want to be answering, what is a real world problem, and can we get that product to actually answer that problem or answer that question. Is it being used as expected? I'm going to show you some examples in just a second here of inventions that were designed for something else but gained prominence through essentially misuse of it. How can it be improved? Right? And so you have to think about all of these companies that once had kind of a stranglehold on the market and now no longer exist, right? Think about Blockbuster or Tower Records. Thanks, Borders Bookstore, right? They had products, but they weren't continuously trying to improve that experience to the point where they got usurped by companies like Netflix or Amazon. Why did it fail? So sometimes this can be a single instance of a product failure. So in the case of the Boeing 737 that had the series of crashes, trying to figure out what happened that led to those crashes. Why isn't the system good enough? Now, sometimes that can be getting feedback from other people who say this product is really failing, or people just stop using the product. Okay, why are they stopping to use the product? But it can also be a case wherein you're brought in to evaluate a product that seems to be really good at doing what it's doing, but you have to establish what about this could be better, right? Why isn't it as good as we want it to be? Does the expected performance meet design requirements? And so depending on what career field you all go into, if you do any sort of government contracting work, frequently you're going to be given a list of requirements at the onset of a project and says, the technology that you are delivering to us needs to be able to meet this criteria, right? Or perform better than this baseline. And so evaluating against that. And sometimes you'll also be asked to say, okay, which system is better? So we brought in and say, hey, we've got these two competing software systems. Can you tell us which one's better? And you have to be able to say why, right? You have to be able to quantify what is the time savings? What is the financial savings? What is the reduction in risk? Things like that. And so getting back to the, is it used as expected? Bubble wrap was originally marketed as wallpaper, right? But it's clearly, I think if you walked into somebody's house and they had bubble wrap hanging on the walls, you'd probably turn right around and walk back out. So that's a crazy person activity. The Slinky was initially designed to stabilize naval equipment on rough seas. And possibly the most morbid, chainsaws were developed as a tool for cutting bones. I should have inserted a Mitch Hedberg joke. I don't know if you all know who Mitch Hedberg is, former stand-up comedian, he's not dead. But he had a whole bit about how he thought Pringles used to be a tennis ball company. But one day, instead of a shipment of rubber, they got a shipment of potatoes. And they were a really chill company, so they decided to just go with it, right? And so thinking about what are these technologies that people have developed that we can now reapply to something else that it wasn't intended for. So when we talk about evaluation, we have two different kind of broad categories, right? Qualitative and quantitative evaluation. Qualitative evaluation is non-numerical data. So for example, any responses you would have to open-ended questions. So if I said, what are your thoughts about your computer? Or describe your experience with the Tesla auto driving feature. Qualitative assessments tend to be very subjective in nature. So when I say subjective, what do I mean? Yeah, individualized, right? People's opinion, right? It's rarely any sort of objective measurement. Quantitative, on the other hand, tends to be very numerical. And it tries to be as objective as possible. Now, one of the issues that people run into a lot is using a numerical scale, but thinking that it means it's fully objective, right? There are a lot of cases wherein you're using a numerical scale, but it's still relatively subjective. It's not the actual ground truth. It's not an objective measurement. And that's fine. There are a lot of great ways to get at numerical subjective data. But don't fool yourself into thinking it's an objective truth when it may in fact be a subjective experience. But objective quantitative measurements would be things like performance, reaction time, accuracy, things like that. So an objective measurement in my previous research, when I'm looking at people's trust in a self-driving car, is how often are they intervening? How often are they stopping the car from driving itself? That's an objective indication of trust. I can ask subjectively, how much do you trust the vehicle? But that objective kind of binary classification of self-driving or manual is a fairly good quantitative measurement for somebody's trust. All right, so for those in here, talk with your neighbor for just a couple minutes. For those on Zoom, I don't know how to do the breakout sessions, and I'm not sure that's going to necessarily be a good thing, but think about one example of a qualitative way and one example of a quantitative way you could try and evaluate something that's a problem or a question you have about your daily experience. So go ahead and talk with your neighbor, and then we'll bring it back together. Oh, okay, that's good to know. Thank you. Mm-hmm. Yeah. You can go join one of these groups here. Anything? Not a single question you have about the way the world works. About some ground truth. Some research question.
What's one you have?
Oh man, where do I start?
Well, just pick like your favorite one.
Does the appearance of a robot affect our willingness to trust it? And
Yeah, the face.
maybe?
Like my little, do you know what a scrub daddy is, the little sponges?
Yes.
Yes.
I have one and I refuse to use it on anything that makes it uglier than it is because I feel like I'm hurting it.
See, there you go.
know,
There's a
like
question.
little face, just-
You personified the scrub.
Yes, and it's happy. I'm just like, I want to leave it as nice as it is. That makes sense though.
See, it's a research question.
It's that way, but
That's the research question. Why is it that way? Why have you anthropomorphized and grown attached
a very expensive sponge.
to a sponge? Yeah. "36 more seconds. Was that?
I feel like this is a tough question. I don't know why, but it's like, I think everybody's got questions, but off the top of my head, I just cannot.
Yeah, I think that serves to highlight, so not to get on my own philosophical rant here. I think it serves to highlight one of the issues with kind of the traditional educational system, right? Every kid asks why or what, or asks all these questions trying to understand. And then you get into school, people say, stop asking those questions. I'm just going to tell you what to think. And so it's rediscovering kind of that passion for, well, why is this the way it is, right? Why is it that Facebook is so addictive? Or why is it that Twitter is seemingly facilitating political divisions? Okay? Asking those questions. All right, so besides what I just said, somebody give me an example of a question they have, and then one qualitative and one quantitative way you can go about it.
Well, I thought of the new scheduling system for how we go about this semester.
Okay.
Like how we have less classes in person, we have more classes in Zoom stuff. So I would say as like a qualitative question to that, like, what are your thoughts on how we're doing these hybrid classes? Do you like it better? Do you like it worse? Stuff like that.
Yeah.
And then for like a quantitative question, be like on a scale of like 1 to 5, with 5 being strongly agreed or a 1 being strongly disagreed, would you recommend a certain style like this, like after the semester, after the pandemic is gone, or do you want to like have a progression of certain Zoom call things, stuff like that?
Exactly. Yeah. So that's a great real world, consistent with kind of what the administration is trying to figure out right now question, right? So what are the ramifications for school in the current environment, right? There are some who are taking it only on Zoom. There are some who are taking it half and half. I don't think there are any classes that I know of on campus that are doing full in-person every day. But what are the ramifications for that? Do people like it? Is it going to affect retention of students? What are perhaps the grade performance impacts on it? So are those who are on Zoom only going to do different than those of y'all who come one day and not come another day? Is there something lost by the fact that I have to wear a mask and you can't see all of my expressions? And I can't see when I assume you all are cackling, laughing at all of my stupid jokes under your mask. What sort of ramifications does that have on the professor, right? Yeah, that's great. That's fantastic. All right. Right, and so when we think about evaluation as a whole, we do it largely for 3 main reasons, right? 1, to try and understand, 1 to diagnose, and another to verify. So to understand, we really do use that qualitative and quantitative approach. We're just trying to understand what's going on in the minds of the user. So I'm working on a project now where we're talking to real-life warfighters about their experience with automation, but it's really open-ended. We just want them to tell us a little bit about what they do and what their experience with automation is, so we can get a better understanding as to what a day in the life of a warfighter looks like with these technologies. Similarly, going through the diagnosis process, you do things like a heuristic evaluation, right? So that's me coming in to a company and saying, based off of what I know about this software, or excuse me, about human factors, this software is likely to disenfranchise users or make people less likely to want to use this, right? Think back to Clippy. Does anybody here remember Clippy? Are you all too young?
From Microsoft Word.
Yeah, from Microsoft Word, right? So for those of y'all who may not remember Clippy, it was this profoundly, what I found, annoying little paperclip that would pop up and say, hey, looks like you're trying to write a letter. Would you like any help? And it was so persistent. And at the time, it was fairly advanced for this sort of AI, this early AI. But it got to the point where people got so annoyed by it, it actually led people to disuse Microsoft Word, right? You can also do a cognitive walkthrough. So if I were to say, okay, describe your job to me. Describe everything you do. Just walk through that so I can get a good understanding as to what the processes are. Now, there's an obvious issue with this. All right. So everybody stick out your hands like you're driving. Now merge into the right lane as if you're driving. Go ahead. And then you come back. So the blinker is not even the issue. So for those of y'all who did it at home, I hope you also have this experience. Everyone I just saw in here went here, they turned right, and they came back to straight. If you do that, you're going to crash on the right barrier. Watch what happens when you actually merge. You'll turn right, and then to straighten back out, you'll turn left. You'll counter steer to straighten out in that lane, right? And so if I asked you the process of merging, chances are every one of you would have said, turn the wheel to the right, then turn it back straight, neglecting part of that aspect of the turn signal there as well. And so it's not always going to be the best approach for understanding how things are done, but it is a fairly good way of getting at what are the step-by-step processes. And then we have the verification. And that's going to be largely, if not exclusively, quantitative. All right? This is us going out and doing the field test. So this is us saying, okay, how much safer is a Tesla with self-driving capabilities than a human? I don't care about your subjective experience of safety. I care about the objective, actual measurement of safety. Again, the plural of anecdote is not data. All right, so as we kind of talked about last time, the best time to get involved in the design process is as early as possible, right? But at different stages of your involvement, you're going to have kind of different types of evaluation techniques you're going to want to use. So at the conceptual phase, this is really where you're going to start using that sort of heuristic evaluation. You don't have anything concrete to test performance metrics with. So you're going to need kind of these more abstract, these more qualitative measures. For the prototype phase, you may do a little bit more of a usability test. And so I'll say, find for me the feature that will allow you to insert a table. right? And now I go look at your actual use of it, and I can also ask, okay, how easy was that to find? A pre-production model, you may push out to a select user base. So if you think back to Google Glass, right? That was released kind of at a beta version. It was not mass consumable, but a handful of people got that technology, and were able to provide not only kind of the subjective experience, but they were able to get a lot of the performance metrics. How good was it at interacting with whatever else it was intending to interact with? And then after that product release, that's when you get kind of that in-service monitoring. So that's sending those performance metrics back to the company. That's figuring out what in the world's going wrong. So I see two of y'all who are using Apple computers. Have y'all updated to Catalina, the operating system?
Yes, but there's like the latest software I think I've been trying to get up to like 16.6. And I swear every time I update it, it keeps saying, "Do you want to go to 16.6?" And I'm like, "Yes, I do."
See, that's a whole usability issue in and of itself. I don't know if y'all have this experience. So for those of you not aware, Apple names all of its software updates. You know, last one was Mojave, this one's Catalina. When I updated to the new software, all of a sudden it routinely bricked my computer. My computer just constantly froze. And it happened on two of my different computers. So I know it wasn't something I downloaded on one of them or something. And so this is kind of the in-service monitoring. And so every time it freezes and shuts down, it opens back up and says, "Would you like to send a report to Apple?" And I only regret that they only have a yes button rather than a hell yes, fix this button. But it's that constant in-service monitoring for them to try to figure out what's going wrong. So during that conceptual phase, those heuristic evaluations, you're going to need to do a literature review, right? Part of this is going to come from years of experience. But when you're brought in to consult, you don't want to just consult with companies that you have absolute expertise in. You may be brought in to consult with companies, like right now, I'm consulting with an artificial intelligence company, but I don't have much expertise with artificial intelligence, but I have expertise with human-machine interaction, right? And so that's where I now can go pull from my expertise, but also do a lot of the reading. And so that reading then informs my design recommendations, right? What I'm doing as a consultant. Because these companies expect me to come and say, here is what the literature says about the best way to proceed with this design. They don't want just my feelings, because they can pay people a heck of a lot less to just give them their feelings about it. And then I can go through that cognitive walkthrough process. So you're considering each task associated with a system interaction and pose a series of questions to highlight the potential problems that may confront somebody when actually trying to perform the sequence of tasks. All right, so let's go back to the stove example. You're cooking on a stove, and I say, okay, tell me what you're going to do to turn off that stove or to deal with a fire on that stove, right? Give me that walkthrough. So examples of that cognitive walkthrough type of questions you would ask, is it likely that the person will perform the right action? Will they hit the wrong button? Does the person even understand what task needs to be performed in that case? Do people know that when there's a fire on the stove, the best thing to do is turn off the source of heat? And if it's a grease fire, don't throw water on it. If there are a sequential series of tasks that need to be performed, Does the person know that that next task can be performed after that first task is performed? Is it intuitive or self-evident, essentially, how to perform that task? Is somebody going to know how to perform it, either from training or just kind of from, design that really kind of tells you how to go about doing things, right? When we think about the door example, having that push plate on the door tells you how to perform an action with that door without you really having to think about it. And then you kind of have this training aspect. Does the person get feedback after performing the task indicating successful completion? Do they know when they've done the right thing? Right? If I'm trying to shut off some sort of power supply to a remote station somewhere, and I hit the button to turn it off, am I going to get some sort of light indicating that, yeah, you turned it off, success? So with this usability testing, we're asking things like, is the system user-friendly? And when we talk about user-friendly designs, we're concerned with things like learnability. So is the system easy to learn, right? Can you pull it out of the box and know exactly how to use it right off the bat? Is it efficient to use? So can you perform the tasks that you want to perform with relatively little action required from you? You also need to consider the memorability. So if you perform a task a whole bunch and then you walk away for a day, week, month, year, can you come back and perform just as well, or is the system still as easy to use after that extended hiatus? Do they elicit a low error rate, either from the individual or the system itself? And then just general satisfaction. Is it pleasant to use? All right, and the best illustration of this satisfaction aspect, go back and look at the early days of the internet. Those web pages were hideous to look at, often had color schemes that were impossible to read. It just wasn't very pleasant to use. Questions about anything we've covered so far? All right. Oh, Casey says, how do you evaluate or measure things like memorability or satisfaction? Yeah, good question. So with memorability, you can look at essentially the performance metrics. So you see what somebody's performance is when they're using the system, and then you evaluate their performance after they come back after that hiatus. Are they able to remember exactly how to do it, or is it taking them longer to actually perform that? Satisfaction could be everything from kind of these qualitative evaluations of how much do you enjoy using it, but it could also be things like how much, under their own volition, are people actually using it, right? And so again, go back to my research, looking at people's trust in the auto parking feature in a Tesla. So one of the things we did to evaluate kind of this trust and this satisfaction was to give them experience auto parking, give them experience just parking themselves, and then say, all right, just do some trials. If you want to auto park, great. If you don't want to, that's fine too. And see, okay, do people actually want to keep using this system? Good question. All right, if you have any other questions, please type them into that chat box or unmute yourself, and I'm happy to answer them. So then we also have the controlled experimentation process. And so especially those of y'all in the humanities are probably very familiar with this sort of controlled experimentation process. But your book outlines kind of these 5 distinct steps. So first, defining the research question and hypothesis. What is the problem you want to solve? Specify the experimental design, right? So you need an experimental design that's actually going to address the questions. Conduct the study, analyze the data, and then draw conclusions and communicate results. And so in this final step, this final process of drawing the conclusion and communicating your results, one of the things you'll notice as you get into kind of reading more in the sciences is that people frequently overstate their data, or they think their data answers a question that it doesn't actually answer. Or sometimes in the most egregious cases, they'll have an answer coming into a project. The data don't support that, and they say, well, there's probably something screwed up with the way we collected the data, right? So data, and so with that research question and hypothesis, what's the relationship between those 2 variables? Or it can be more than 2 variables. So, for example, does using a smartphone while driving cause more driving errors? All right, so we know that texting on a phone negatively impacts driving performance. What are your guesses? Does talking on a phone hurt performance? What's that? It can. What about if I give you a hands-free? Does that hurt performance? Yes, exactly. Because the issue with cell phones and driving is not preoccupation of your eyes or your hands, it's the preoccupation of your mind, right? And so you have these issues wherein people pass these insane laws that are decoupled from science that say, okay, well, you can talk on the phone, but only if it's a hand-free headset. That doesn't increase safety whatsoever, right? And so thinking about what are these things that we have maybe this non-intuitive expectation of the results, but what are the research questions that we can ask? Making sure you're asking that right research question. So let's get back to face mask wearing, right? So one research question would be, do face masks reduce the spread, like the spray of any of these COVID-19 particles? To which the answer is yes. But you can also ask, do face masks help reduce overall transmission within a community? And there, it can be a little bit more ambiguous. And one of the reasons it's more ambiguous is because people do what I've been doing this whole time of touching their masks, right? Masks alone are great. They help slow the spread. They help stop the spread from people to people. But you have to consider that other behavioral component, right? So if now I take off my mask, I grab it with my hand, and then I rub my face, a lot of good the mask just did over the last hour and a half, right? So what are those behavioral things we need to be thinking about in addition? Making sure we're asking the right question. The right question is not just, does having the fabric here help reduce, but what are the overarching considerations we need to make about people's behavior to help also amplify that? And so when we get into design, we have our independent variables, we have our dependent variables. I'm sure this is a review for a lot of y'all. Independent variables are just, what are those that you're manipulating? So in the case of cell phone while driving, we'll say you're either texting, you're talking with your hands, or you've got a hands-free headset. Those are the independent variables. Dependent variable is what are you interested in evaluating, right? And so, again, in the cell phone example, we're interested in driving performance. And then you have these series of confounding variables. The confounding variables are variables that have influence from the outside on that relationship. Right? So there's a correlation between ice cream sales and shark attacks. That's true. But do we think that people getting ice cream then go attract the sharks in the water? Or do we think that people who get attacked by a shark go quell the anxiety of having just had a limb bitten off by getting a dilly bar? Probably not, right? There's some sort of confounding variable. In this case, it's probably the fact that as temperature rises, more people go out in the ocean and more people get ice cream, right? That's the confounding variable that could influence those results. I already gave away the first answer. Whoops. But let's say, okay, what is a potential confounding variable for smartphone use while driving? Yeah, exactly. So we have to think about, okay, well, what are the environments in which we have to consider this, right? Maybe there's not really any sort of effect in stop and go traffic, or maybe it's worse than stop and go traffic, right? Or maybe it's really bad in rainy days like we have out there. Exactly. All right, so what about how might different levels of transparency affect your trust in a self-driving car? What would be the independent variables? Exactly, levels of transparency. What would the dependent variables be? Dependent variable. What's that? Yeah, trust, exactly. And then somebody give me an example of a potential confounding variable that could affect this. Yeah. What's that? Yeah, exactly. So maybe what happens while you're in that self-driving car? Maybe somebody cuts you off and you have a close call, right? So that could potentially influence it.
I think individual characteristics take place too, because some people are innately more trusting than others.
Yeah, exactly. So individual differences. So things like risk-taking preferences. So that was another thing we did in one of our studies. We took a look at, okay, do those who have a higher tolerance or a higher preference for taking risks tend to let the system do what it's going to do? Exactly. And so the goal of any sort of controlled experimentation is minimize any of those confounding variables, reduce any sort of risk you can have from those influencing your data, and establish as well as you can what influence the IVs have on the DVs. And so we also have a classification of within subjects versus between subjects designs. A within subjects design, sometimes also called a repeated measures design, means that every subject gets every level of the independent variable. So if we're doing our cell phone example, everybody in here drives with, drives while texting, and then everybody drives while talking on the phone with their hands, and then everybody drives with a hands-free headset. Between subjects design means we're going to split it up. And so a third of this room is going to get the texting manipulation. Another third is going to get the talking with your hand. And the last third is going to get the hands-free headset. So who can think of an example wherein we may want to use a within subjects design or a between subjects design and not the other? Drug trials, yeah, exactly. So if you're doing any sort of drug manipulation, you can't really give everybody both the placebo and the psychoactive substance, right? Because now you're going to have some sort of carryover effect. You're going to have an issue wherein, okay, you got better when I gave you the drug, but now I have to give you the placebo. Well, you're still better, right? There's a carryover there. Yeah, anytime you want one group to be blind to the manipulation, you're going to have to do that between subjects. The benefit of doing it within subjects is statistically, you require fewer participants to be able to establish probabilistically whether that effect was due to chance or due to an actual variation in the real world. And so a within subjects design makes it a lot easier for the researcher. Less time and resources have to be devoted to collecting that data, but it's not always feasible. You also have what we call mixed designs. And so there could be a factor that has to be, or that we want to be between subjects. There could be another factor that we want or has to be within subject, or between, or whatever one I didn't just say. And so, for example, let's say we're interested in whether there's any difference between men and women's driving performance when they text or not. What would be the between subjects manipulation? Gender, yeah, exactly. So we can't assign you for one trial to be a man and then for the other trial to be a woman and then see what your overall performance is. But then within subjects, we can have you texting and we can have you not texting. And so we have this mixed design where now we can see the main effects for gender on driving performance, the main effects for texting on driving performance, and then what we call the interaction between it. So maybe women are better drivers than men when they're not texting, but when they're texting, maybe men are better at driving and texting than are women. All right, we're going to skip that one. Any questions so far about what we've covered? I like having the window in the back of the room because it gives me something nice to look at, except for when the apocalypse is on its way through the trees. Good Lord. All right, well, if you guys lose signal from Zoom here, you'll know we all died. All right. What's that? I know. At least we're on the second floor, so it can't flood us out. Yeah. All right. So when we're talking about designs, we can talk about a one-factor design, a two-factor design, multifactorial. So one-factor design is looking at just one factor, right? Is there a difference between men and women on driving performance? One factor. And in this case, that factor is gender, exactly. Yep. You can then have a two-factor design. So how does transparency and risk-taking behavior affect a person's willingness to trust automation? So what are the two factors in this case? Yes, so transparency and risk-taking behavior, exactly. And that trust is that dependent variable. So again, the benefits of a two-factor design is it allows us to see not only the main effects, So how does transparency affect our trust? And how does risk-taking affect our trust? But also, how do they interact? Let's see if I can get, come on now. All right, so, here we go. So let's say we have the transparency down here. So we'll call that low transparency. We'll call that high transparency. And then risk-taking behavior, we'll call that high risk and low risk. And then we have the trust on the y-axis. And so let's say at low levels of transparency, there is high trust for the high risk and low trust for the low risk. We can then look at the high transparency. And so maybe for high transparency, we have high trust for the low risk and high trust for the high risk, right? And so now what we're interested in is not only is there a difference between low transparency and high transparency, we're also interested in, is there a difference between essentially the triangles and the circles on average? And then with that interaction, we can say, okay, look, the difference between these two varies as a function of their position on that x-axis, right? So it allows us a much more complex understanding of what's going on than just a one-factor analysis. Then you can get something like a three-factor design, right? Are there differences between trust and automation as a function of gender, age, and socioeconomic status? However, the more factors you add, the more complex the picture becomes, right? So you can understand what an interaction would be, like I just described here. There'd be an interaction between two different factors. But with three factors, you can have what's called a three-way interaction. And I'm not going to try to draw it here, but it's this idea that the difference potentially lays in one combination of these three factors. So maybe men who are older and have higher SES tend to trust it more than do men who are younger and have higher SES and every other one of those factorial combinations. Yeah. Socioeconomic status. Not important for this other than it's just a factor. So once we have our variables of interest, we have to operationalize it. Right? And so I've been talking about trust so far, but I haven't operationalized trust. What do I mean by trust? Let's talk about even just the cognitive construct of trust. When I say, do you trust somebody? What is your first thought? Right? Are you willing to rely on them? Potentially that's it. Maybe it's the reliance in combination with some sort of risk associated with failure of that reliance. Maybe it's more complex than just a single measure. Maybe y'all trust me to be up here and lecture to you every day, but you wouldn't trust me to help you change your tire, especially if it's raining, right? Yeah, Andrew says, are you confident that they're benevolent? Exactly, right? And so you can start to see how the same word trust could potentially mean a lot of different things. So it could be, again, the self-reported level of trust. It could be a behavioral measure, so number of interventions, number of times I take over from that self-driving car. Maybe it's the reaction time. You know, maybe my foot's just hovering right over that brake pedal. So the minute that car screws up, I'm ready to step on brake. Maybe it's heart rate variability. Maybe it's not even a behavioral thing. Maybe I've hooked you up to an EKG, an electrocardiogram, right? And so now I'm looking at your heart rate variability as an indicator of trust. So even if there are no differences in self-report and no differences in behavior, I'm able to get a lot more nuanced picture of your trust in that system because of your heart rate variability, or things like EEG, right? So electroencephalogram, it's a brain recording, right? So maybe you're going to have different patterns of activation in your brain as a function of your trust. So once we've collected the data, we've operationalized it in the way we want, right? One of the debates you'll see a whole bunch in academia is over this operationalization, right? You're not thinking of trust in the right way. You're not thinking of, you know, whatever it is, in this case, any interpersonal interaction, right? In the right way. But once we've operationalized it, once we've collected all of our data, we have to do our analyses. And so at the undergraduate level, you'll be talking about things like correlations or regressions, right? And fun fact, regressions are actually kind of the foundation behind machine learning and artificial intelligence. So if you understand regressions, you can start understanding and developing your understanding of machine learning. And so when we run analysis, we get a, quote, statistical significance value, right? And so this is it's supposed to be, and I'll get on that tangent in a second, it's supposed to be the probabilistic value determining how likely it is that our results were by chance rather than our results were because of a ground truth we observed. All right, so let's think about flipping a coin. What's more likely, that I get 100% heads if I flip a coin twice, or 100% heads if I flip a coin 100 times? Twice, right? It's just by chance, you've got a 1/4 probability that it's going to come up heads both times. All right, but once you get out to 100 coin flips, I don't know what that comes out to. Right? And so we have this understanding that based off of our sample size there, the result is much more likely due to chance if we just flipped it twice than if we flipped it 100 times. And so in performing these types of analyses, we have two different types of potential errors we can make with our data. First one, we call it type 1, or a false positive. And a false positive is you saying there is an effect when there's no effect. So let's say there really was no difference between men and women on driving ability, but I went out and collected data, and my data says that women were actually better drivers than men, right? The ground truth is that there's no difference between the genders, right? If we were all knowing, we would know that. But our data said there was a difference. As such, we've committed a type 1 error, a false positive error. You then have type 2, which are false negative errors. So those are the type of errors where it says, no, there's no effect, when there really is an effect in the real world. And so you can think of these types of errors in terms of like COVID testing, right? So you go get your COVID test. You could have it come back and say you're positive when you actually are positive. You could have it come back and say you're negative when you really are negative. You could also have a type 1 error, right? Where it could say, actually, Or it could say you're positive when actually you don't have COVID. Or you could have a type 2 error, which just says, nope, you're good. No COVID here, but you do have COVID, right? And so you can think about prioritizing what type of error you'd rather have based off of the circumstance. Right? So let's think about the TSA screening, right? You're going through TSA and they're searching everybody's bags. Would you rather those TSA agents have a have a type 1 or a type 2 error in detecting weapons? Type 1, yes, right? You'd rather have a little bit extra inconvenience with having your bag pulled out than having them just wave through bombs and knives, right? And so the simple and easy way to remember type 1 being positive and type 2 being a false negative is just by simply drawing it, right? You have type 1, Roman numeral, finish it out as a P, type 2 as an N. And I only point this out because you'll hear type 1 and type 2 from people a lot, and students always struggle to remember the difference between them. I struggle to remember it. But if you can remember and talk about type 1 versus type 2 errors, you're going to sound a lot smarter. So let's represent this graphically, right? So we have two different bell curves, right? Normal distributions. The one on the left is the null distribution, or we could call this the noise distribution. The one on the right is the alternative distribution, or the signal plus the noise distribution. Right? And what we are trying to do is be able to say, based off of our understanding of our data, we want to be confident that we're either getting the right answer or we're making a mistake in a specific direction. So if we set our decision criterion right down the middle like we have here, we have made it that it's equally likely we're going to get a type 1 versus a type 2 error. Conversely, if we move the decision criterion to the right, so can somebody think of an example wherein we may want to enhance the type 2 error or minimize a type 1 error? All right, so let's say you're a broke college or graduate student, and you're trying to find your significant other, but you can't afford to go out on a whole bunch of dates with people who turn out not to be the right person. And so we say, all right, well, it's better for us to reject the right person than to pay for a date with the wrong person, right? And so in this case, we are minimizing the type 1 errors. We're willing to say no dates with anybody unless we are definitively positive that it's the right person, over paying for a date with the wrong person. This would be more representative of that TSA example. So we are minimizing the type 2 errors, represented down here, and maximizing the type 1, right? Because this way we're saying, yes, there's a weapon. We're saying, no, there's no weapon here. And you can see by shifting this decision criterion, and this x-axis can be, you know, anything, a level of certainty. It could be a certain color, right? They now have density scanners for the TSA. But by shifting this decision criterion along that x-axis, you've now enhanced the likelihood of getting one type of error over another. And we'll talk later in the semester, getting into a little bit more of the signal detection theory approach, where you can actually start quantifying the cost associated with this decision criterion. Right? So now we can apply it to the TSA and say, okay, what is the time cost associated with us saying, we want to make sure we get 100% of the weapons. Well, we now know we're going to get a whole bunch of things that are not weapons. So how much extra time is that costing us? For every 1 unit increase in performance, what are the consequences? So I kind of previewed this just a few minutes ago. For any of y'all who have, at least in the humanities, taken a statistics class, we talk about the p-values, right? I don't know in engineering if it's as focused on, but p-values tend to fail to replicate a lot more frequently than they should, right? Just kind of from a theoretical perspective. Right? So if you have a p-value of 0.05, most people would think that it's just going to fail to replicate that same effect 5% of the time. In reality, it fails to replicate about 1/3 of the time. Right? And so a few years ago, there was a paper released in Psychology that asked psychologists to replicate 100 of the most popular studies in psychology, or most influential studies in psychology. And they found that between about 1/3 and 1/2 of them failed to replicate. And everybody said, holy crap, what is psychology doing that's so kind of not by the book that they're failing to replicate so many of these? And then other fields started doing it. And they started finding the same thing in medicine, in cancer research, stuff like that, right? So there are serious ramifications for misapplication of correct statistical approaches. It also forces you to think in the binary, right? It's either significant or not. It's also not representative of an effect size, right? And so sometimes you'll hear things like, eat more cashews and you'll live longer. Well, in reality, it may be that you have to eat a pound of cashews every day in exchange for 15 minutes longer life on average. That's not really a meaningful effect. And so there are alternatives, things like confidence intervals and effect sizes, Bayesian statistics, probability of replication. So you don't really have to know how to do these, but I do want you all to know, as good scientists, that there are serious issues with kind of the scientific standard, and yet we still kind of adhere to that scientific standard. And then lastly, we're going to talk about validity, right? So we can think about construct, internal, and external validity. And construct validity is, am I measuring what I actually intend to be measuring? Right? If I want to be measuring trust, am I actually measuring trust, or am I measuring fear? Right? If my behavioral measure of trust, is interventions, then stopping the car from driving itself, is that actually a measure of how much they trust, or is that a measure of how much they're afraid of the consequences of the system failing? You then have internal validity. So if I successfully limited the influence of confounding variables, have I created an experimental setup that does as good of a job as one can possibly do to limit any sort of influence coming from the outside on the internal state of the testing? And then, perhaps the biggest concern for human factors researchers and engineers is the external validity. Can I extrapolate my results to the greater population outside of the research setting? Right? It's often levied against psychology, and I think very appropriately, that psychology is not the study of the human mind, it's the study of the 18 to 22-year-old mind, right? So how well can we extrapolate things from what we're finding in our lab setting to the real world? Now, some things, there may be no reason to believe that it would be different, right? The actual functioning of your visual system is not going to change. I mean, the performance of your visual system will change, but the actual functioning of your visual system won't change from now until you're 80. It's not like you grow a whole new visual cortex. And making sure that the results I'm getting are as externally valid as possible. If I want to know people's behavior in self-driving cars, it doesn't make sense to put them in an airplane simulator in my lab. It makes sense to try to get out into the real world and have them interact with a self-driving car. Any questions about what we covered today? Cool. I will see the contingent of y'all. Actually, no, I think Tuesday is actually going to be our first guest lecture. Somebody can verify. It is? Perfect. Yeah. So I will send out the Zoom link for that. Again, there's going to be Demi Skipper from Open Table. She works on the product development of their app there. I would encourage y'all to just download the app and kind of take a look at it and see what sort of things they're doing with the app. And we will get to talk to her about that. But we will still have class on Thursday. Y'all will be on Zoom. Zoomies, you will be in person. So I'll stick around if anybody has any questions. Otherwise, I will see you next time.
Just to reiterate.
Yeah.
Tuesday, we're not.
Tuesday, it's going to be a completely remote. Yes. So those of y'all who are here will be remote. It'll be, yep. I'm sorry?
The name of the app?
Open Table. Yeah. It's also a website, but. Good to go. Oh, good. We survived.
I think though, because it's pretty and everything.